In this video, we're going to prove the quotient rule for derivatives. The quotient rule needs to be used anytime you're taking the derivative of one function divided by another function. So in this case, we have the derivative with respect to x of u of x divided by v of x. As with all of our proofs, we're going to use the limit definition of the derivative up in the top left corner. The limit as h approaches 0 of f of x plus h minus f of x all over h. So I've already thrown our function u of x over v of x into that difference quotient and that limit. So we now have the limit as h approaches 0 of u of x plus h over v of x plus h minus u of x over v of x all over h. The first step in dealing with any indeterminate limits like this one, where we have a fraction within a fraction or complex fraction, is to simplify that complex fraction. So we'll simplify the complex fraction by getting a common denominator of the terms in the numerator of the bigger fraction. That common denominator will be v of x plus h times v of x. So we'll have to multiply the first fraction by v of x over v of x, and the second fraction by v of x plus h over v of x plus h. So that will give us u of x plus h times v of x over v of x plus h times v of x minus u of x times v of x plus h over v of x plus h times v of x. And that's all over h. In the next step, we'll combine together the two fractions in the numerator. And this h that's overall in the denominator of the whole thing can be thrown in with the denominator of this numerator, because we could treat h as if it was h over 1, giving us a fraction divided by another fraction, which means we'd multiply it by the reciprocal. We'd be multiplying, we took this, we'd be multiplying by 1 over h, and so the h would go into the denominator and the numerator would remain unchanged. So we now have a limit as h approaches 0 of u of x plus h times v of x minus u of x times v of x plus h all over v of x plus h times v of x times h. And similarly to when we did the product rule, we're going to have to add some terms and subtract those same terms from our numerator. In this case, the terms that work are u of x, v of x. So we'll add that and subtract that from our numerator. And then again, similarly to what we did with the product rule, we're going to take a look at this first term and this last term, and we're going to separate those into their own limit. And then we're also going to do the same with the second and third terms. When we do the second and third terms, we're going to factor out a -1 from them so that we have a minus sign between our two limits. So from the first and the fourth terms, we're going to factor out the v of x. So we're going to end up with a limit as h approaches 0 of the v of x that we're factoring out times what was left, which was u of x plus h minus u of x, all over the v of x plus h times the v of x times the h. And then we're going to factor out a -1 from the other two terms, as well as the common term there, which is u of x. So if I factor out a u of x, I'm going to get a limit as h approaches 0 of u of x, and then times whatever's left, well, of v of x plus h, and then we factor out a -1, so minus a v of x. And that's all over v of x plus h times v of x times h. we're now going to actually separate these two limits into 5 of their own limits. First thing we're going to recognize is that v of x plus h times v of x is in the denominator of both of these limits. So we're going to separate that down into its own limit in the denominator of the whole thing. Then we're going to separate the v of x, the u of x plus h minus u of x over h, and this u of x and this v of x plus h minus v of x over h into their own limits, leaving us with the limit as h approaches 0 of v of x times the limit as h approaches 0 of u of x plus h minus u of x over h, which we should recognize as the limit definition of the derivative of u, and then minus the limit as h approaches 0 of u of x times the limit as h approaches 0 of v of x plus h minus v of x over h, all over a new limit, the limit as h approaches 0 of the v of x plus h times v of x that was in those two denominators. And now we should be able to evaluate all 5 of these limits. The limit as h approaches 0 v of x is simply just v of x. The limit as h approaches 0 of the difference quotient of u is the derivative of u, so u prime of x. We have minus the limit as h approaches 0 of u of x, which is just u of x. And the limit as h approaches 0 of the difference quotient of v of x plus h minus v of x over h, which is the derivative of v or v prime, all divided by, as we do the limit as h approaches 0 of v of x plus h, that's v of x, and then times another v of x is v of x squared. And this is the quotient rule for derivatives. The derivative of u of x divided by v of x equals v of x times the derivative of u minus u of x times the derivative of v, all divided by v of x squared.